Hey, you guys, it's Miss All Day. Happy Thursday. We're going to get started on our last lesson for Chapter 9. So today is Thursday, the 23rd. 20. All right. For Section 9.7, the page numbers are right here. So if you want to go ahead and open your book to page 594, we're going to do similarity transformations. So basically, we're doing a transformation where the figure is going to be similar. It may not actually be congruent, but it's going to be similar. You can use compositions of rigid motions and dilations to help you understand properties of similarity. All right, so what we're going to start with this first example, let's go ahead and graph triangle DEF. Now, in your book, it's already graphed, so you could look there and graph it on your paper, or you can just do it from here. So I'm going to do 2, 0, that's D. I'm going to do 1, 4, and that's E. And then I'm going to do 4, 2, and that's F. All right, so we're going to connect the dots, and we're going to see what kind of similarity transformation we're going to do. What is the image? Because remember, this is the pre-image. The pre-image is the original one. They're asking us, what is the image of triangle DEF when you apply the composition right here? Now, you see how it's being read. I'm going to get rid of that question mark just for a minute. Really, what you're saying is you're actually going to reflect across the y-axis and then dilate by a factor of 1.5. And they don't have which point they're dilating it around. That's because you're dilating it around the origin. But you are doing this to triangle DEF. And because you're doing two things, you're going to end up with triangle D prime prime, E prime prime, F prime prime. All right? So they could have written it that way. But I want you to take note that you always do the second one first when you have that little open circle in between them. All right, so we're going to reflect over the y-axis. So the y-axis is in blue. I'm tracing it right now. We're going to reflect over the y-axis. So I'll use darker blue. E is 1 unit to the right. So E prime will be 1 unit to the left. F is 4 units to the right. So F prime will be 4 units to the left. D is 2 units past the origin, and D prime will be 2 units to the left. So that's D prime. All right, connect your dots. Feel free to pause this at any time. I'm going to try to make better use of your time, okay? All right, so now we did the reflection. So the next thing we're going to have to do is we're going to dilate it. So what we're going to have to do is multiply the x value and the y value of each of the points. You're going to multiply them by the 1.5. All right, so let's start off with D. And when we do this, we're not really multiplying these points. And you're like, well, that's what you just said. Well, if that had been my first step, then that would have been correct. And it's a common mistake, so I like making mistakes so you can catch me in them, and also so it will help you remember not to do that. We are not going to be dilating these points. We are dilating the new point. So D prime is -2, 0, and E prime is -1, 4, and F prime is -4, 2. Those are the points that we're going to have to multiply by 1.5. All right, so we'll do that in a different color. We'll do purple. So we're going to times these by 1.5, but separately. So when you multiply a negative times a positive, your D prime prime is going to, the first one, -2 times 1.5 is going to be negative. And think of it as doubling $1.50. So that's going to be 3. Now, when you multiply 0 times 1.5, you're going to get 0. All right, let's just do all of them and then we'll go plot them. All right, let's look at E prime prime. If you multiply -1 times 1.5, you're going to get -1.5. If you multiply 4 times 1.5, think of that as $1.50 4 times. So you should get 6 because $1.50 2 times was 3. So 4 times should be double that, 6. All right, let's go to F prime prime. So -4 times 1.5 is just going to be -6. And then 2 times 1.5 is going to be a positive 3. Okay, so now we have the points that we did a dilation on them. Okay, so let's go to negative 3, 0, and that's d prime prime. And I'm going to erase d prime, e prime, and f prime because I think they're going to be in my way. All right, e prime prime is going to be negative 1.5, and then I'm going to go up 6, 2, 4, 6. So way up here is e prime prime. All right, and then f prime prime is going to be 2, 4, 6, negative 6 to the left, and then up 3, and that's f prime prime. And then we're going to connect those, and this is our ending result. This is our resulting figure. This is what you call the image. F prime prime, E prime prime, D prime prime, triangle. Now, they called it triangle DEF, so we can call it triangle D prime prime, E prime prime, F prime prime. All right, so that was problem 1 on page 594. And you see on the next page, you have the got it problem, page 595. So this got it problem is the one you have to do and turn in. So I'm not going to do that one. I'm going to leave that one right there for you to do. So when you get finished with your notes today, you can just submit the got it problem on the notes, and you don't have to do practice problems today if you don't want to. If you want to do them, you can, but if you don't have to. You can just do the got it. That's what I'm requiring for today's lesson. All right, let's move on to part 2. This is page 595, describing transformations. It says, what is a composition of rigid motions and a dilation that maps triangle RST to PYZ? Now, first of all, I can tell that they're already positioned a little bit differently, but I'm thinking that if I rotate it 180 degrees, that I could get it down into this quadrant. See, this is quadrant 1, and this is quadrant 3. Remember, it goes backwards. 1, 2, 3, 4. So if I want to take the original, which is triangle RST, okay, that's in the first quadrant, and I want to put it in the third quadrant, the easiest way for me to get it down there is to go ahead and rotate it. So I'm pretty sure you would agree that if I connected R and P, that you would say that would be a 180 degree rotation. So that's pretty simple, right? All right, so I'm going to go off to the side and show you how to show your work for that. All right, so I'm going to rotate it 180 degrees about the origin. And what am I going to rotate? I'm going to rotate each point that has an XY coordinate. And remember, I'm going from first quadrant to the second quadrant, so I should have opposite X and Y coordinates. Okay? All right, so we're going to start with the first one. If I rotate 180 degrees about the origin, I'm going to do point R. Let's see what R is. R is 1, 1. So let's just change both of those to R prime, which is negative 1, negative 1. All right, let's plot that. This is R prime. All right, let's rotate again 180 degrees. We rotate one point at a time about the origin. So let's do S this time. And this is going to be S prime. So let's go look at S. That's 1, 3. So we're going to change those signs to negative 1, negative 3 because it's a rotation of 180 degrees. All right, so let's plot that one. Negative 1, negative 3. Way down here, right? And that's going to be S prime. All right, now let's rotate 180 degrees about the origin. The last point is T. That's going to result into T prime. Let's go see what T coordinates are. That's 1, 2, 3, 1. So 3, 1. All right, so let's make both of those negative. Negative 3, negative 1. So we're going to go negative 3 and then down 1. So that's going to be T prime. Okay, and I'm going to connect the dots. I'm going to make it a little bit darker so you can see where it's at. That's our new figure. That's the resulting figure. All right, now I've got to turn triangle R prime, S prime, and T prime into triangle. Let me circle this with blue so you know where I'm at. Triangle P prime, Y prime, Z prime. All right, so you can tell I'm going to have to enlarge it. So that's going to be a dilation. So let's look here. This side is 2 units long, and this side is 4 units long. All right, so remember, whenever you're trying to figure out how you're dilating it, you can probably already see that it's going to be 2. But remember that you do the image first, and you do the pre-image second. So the image is always going to be the numerator, and the pre-image is always going to be in the denominator. So that's going to be 4 over 2, which is 2. So we're going to do a dilation of 2. So we're going to do a dilation of 2. We're going to do it to each x and y coordinate. And so it's going to look like this. We're going to double our x, and then we're going to double our y. All right, now remember, these are new coordinates. So each time I can't look at this original one up here in the quadrant 1. I have to look at the one that's in quadrant 3. So I'm going to go ahead and write down what R prime prime, S prime prime, and T prime prime are, so we don't have to think. We'll think smarter, not harder. So R prime prime is -1, -1. Oh, we have them right here. What am I thinking? I'll just circle them. Hello, all day. If you're going to think smarter, not harder, do it. Haha. Okay, now we're good. All right, so we're going to take those and we're going to double them. All right, so I'm going to do a dilation by a scale factor of 2 to -1, -1, and that is R prime. But look what it's going to turn into. It's going to turn into P. Okay, so we're not going to be calling this one R prime prime. Okay, because if you look up here, I'm going to do this in neon green. This R was changed to R prime, and it matches up in the same location as P. So this one's green and this one's green. Okay, so that's where it changed its spot to. All right, so if we double -1, we're going to get -2. And so that's going to be -2, -2. We'll do those in a minute. Let's go ahead and dilate by a scale factor of 2, -1, -3. All right, that's going to be point Y. That's the second point because we're looking at S prime prime. All right, so we're going to take the -1, -3, and we're going to multiply it by 2. So -1 times 2 is -2, and 2 times -3 is -6. All right, so we have one more point to do. Let's see if I can pull this up a little bit so you can see it. Dilation by a scale factor of 2 to -3, -1. Now that was T prime, but if you look up, T prime becomes Z whenever it is dilated. So this is going to be Z. So multiply both of those by 2. You should get -6, -2. All right, now I'm going to erase the red marking if I can and the smiley face because we don't need it. And if you look at the picture, you should be able to tell that, I'll do this in kind of a pinkish color, that P is -2, -2. Check. Y is -6. I'm sorry, not Y. Z. Z is -6, -2. And then Y is -2, -6. So we see that we did that one. All right, so what did we do? We described the transformation that happened. We had to figure it out. So if they said, okay, show me using like just a statement, what in the world you just did. All right, I'm going to write it in black. This is what we did. We dilated by a scale factor of 2. And then, didn't mean to put a comma. Then we rotated by 180 degrees about the origin. So that right there, dilating by a factor of 2 and rotating 180 degrees about the origin, that's what we did. Now remember, you always do the second one first. When you have that little open circle, when you're doing a composition, you're going to do the second one first. So 180 degree rotation about the origin, followed by dilation with a scale factor of 2, maps triangle RST to triangle PYZ. All right, now go ahead and go to the next page. This is your got it problem number 2. So got it problem. This is number 2. So this is the other one you'll be doing for me today. We're kind of making the lessons a little bit more concise. All right, so that's the one you'll do for me. Just like above here, you'll do the got it 1, and then you'll do the got it 2. All right, let's move on. All right, this is going to be located, the information for this, if you're following me in your book, is going to be located on page 596. All right, in examples 1 through 4 above, the figures appear to have the same shape, but different sizes. Compositions of rigid motions and dilations map pre-images to similar images. For this reason, they are called similarity transformations. Two figures are similar if and only if there is a similar transformation that maps one figure onto the other. So that's just kind of reviewing what we just did using words. All right, part 3 is our last section, I think, or we might have one more. Yeah, we have 2 more sections. All right, part 3, finding similarity transformations. All right, so you were given these 2 pictures. Is there a similarity transformation that maps triangle PAQ to triangle TNO? And if so, identify the similarity transformation and write a similarity statement. And if not, explain. All right, the first thing we want to do when something's similar is, remember, we want to see if they're proportional. We want to see if they're proportional. So let's see. Let's just say that PA is yay units long. We don't know how many. Let's just say that PA is 1 unit. Okay? And let's say that TN, let's just say that it's 2 units. We don't know what they are. This could be 1, 3. Okay? We don't know the scale factor here. This could be 2, 4. Okay? So we're just going to say, since we don't know what they are, we're going to just say, let's pretend like they're that. So if I was doing a scale factor, and we're not going to use those numbers, that was just kind of just to set it up, just to show you it's okay that we don't know. Okay? I just marked the segment that's in between the 2 angles. So the scale factor, let's do the scale factor of PA, which is the one on the left, to the scale to TN. That's the scale factor. PA, the triangle on the left, to TN, which represents the segment in the triangle on the right. Okay, that's the scale factor. Let's just say the scale factor equals K. All right, so let's say that we can already see that these 2 angles are congruent with the 2 angles in this triangle. So because of the third angles theorem, you guys know what? You know that the third angle has to be congruent to the third angle. So you know that angle Q has to be congruent to angle O. So if you look at this part right here, angle, side angle, and over here, angle, side angle, you're like, okay, hey, these are similar. ASA, similarity. So what did you do to figure out whether or not they were similar? Well, we know that they were dilated by some kind of scale factor. We're going to call it K. Okay, and we can see that they're similar because we can tell ASA, right? That's a similarity statement. So DK and rigid motions maps triangle, we'll say P prime, A prime, Q prime onto triangle TNO. Now, why did I put this P prime, A prime, Q prime? Okay, because if you actually were taking, and I'm going to erase a whole bunch of material just to kind of get you to focus on the triangles for a minute. So I'm going to look at blue. If you took this triangle right here and you moved it closer to that one. So let's say I moved it and I put it right here. Okay, it just became P prime, A prime, Q prime. So what they're asking us is there a similarity transformation that maps one triangle onto the other? So if I'm going to map one triangle onto the other, I'm going to have to move it. So I literally moved it over there. Now, I didn't put exactly what I did. I didn't say that I rotated it, and I didn't say that I translated, but that's really what I did. I probably took the original triangle, and I maybe took this right here, and I rotated and maybe put it right here. Okay? So now this would be, okay, I could just rotate it. And then I went and slid it over there. That's a translation. We're not being picky on tell me exactly what you did. They just want to know, could you map it over there? Yes. If I dilated it and I used rigid motions, I'm not saying which rigid motions I used, but if I used them, I could slide it over there and one could be on top of the other. I would dilate it. That way these corners right here would end up being the same as they were on the left-hand side of the page. So you're like, well, that's kind of vague. Yeah, it is. Now, for this one down here that you're fixing to do, this is the got it problem number 3 that you're going to do today. They ask, is there a similarity transformation that maps one triangle onto the other? If so, identify the similarity transformation and write a similarity statement. Now remember, I'm just going to refresh your memory. I'm not going to do this one for you. If we were trying to figure out if these were similar using side similarity statement, we're going to take, and I'm just going to set it up for you and let you do the rest. 10, 12, and 16 and put them in a row and put them all as the numerators. 10, 12, 16. I put them in order from smallest to largest. Now do the same thing with the triangle on the right. Take those 12, 16, and 20 and do it like this. 12, 16, and 20. Now put the fraction bar in between. You're going to reduce each one of those and see if they're equal. Well, if they're all equal, then they're proportional, and you know that they're similar. And so you're going to have to identify the similarity transformation and write me a similarity statement. So if I'm going to finish the one above. I just wanted to go down there because that's a little bit different, and that's the got it problem you're going to end up doing by yourself. So I wrote, I identified the similarity transformation as a dilation and rigid motions, and I wrote a similarity statement. But I could also do it like this. I could say that I dilated by a scale factor. I dilated triangle PAQ, and I ended up with triangle P prime, A prime, Q prime. Okay, we got to kind of bring that into the picture. Okay, so that's really the first thing I did. And then I realized that when I did that all I had to do was dilate and do a couple of rigid motions, and I could put one on top of the other. And if I took triangle P prime, A prime, Q prime, and put it on top of triangle TNO, then I would be dilating it and enlarging it by a scale factor, but we just don't know what that scale factor is. In this problem you're fixing to do, you're fixing to find out what the scale factor is. So you're going to be able to say that. All right, part 4, last section, determining similarity. A new company is using a computer program to design its logo. Are the two figures used in the logo so far similar? All right. So just glance in the book. It says if you can find a similarity transformation between two figures, then you know they're similar. All right, so we have the smaller lightning bolt and you have the larger lightning bolt. And all you have to do is translate it, right? And enlarge it. You can tell if you were going from small to large, this is what you would do. So first of all, are the two figures used in the logo so far similar? Yes. Well, how do you know that? I'm going to say the smaller lightning, and we're not going to be super specific. The smaller lightning bolt can be translated and enlarged, or you could say dilated if you wanted to, but I'm going to be more specific and say enlarged by a scale factor. And if I translated it, which is sliding it, and enlarged it by a scale factor, then it would map it. So the smaller lightning can be translated and enlarged by a scale factor to map onto the larger one. All right. So for your last got it problem that you're going to do, it is down here in the bottom right hand corner. This is your got it problem number 4. Okay. This other one here was your got it number 3. Are the figures below similar? And you're going to give me a similar statement to the one I just wrote, but it has to do with the smiley faces. So, your work for today, instead of assigning you extra practice problems, we just decided that we were going to assign you the got it problems. So got it 1, got it 2, got it 3, and got it 4. And then you can upload these notes, and that will be your assignment for today. All right, you guys. I shall see you tomorrow, maybe. I'm thinking about doing a Zoom meeting. So I'll keep you posted, okay? Talk to you later. Bye.